So when we think of collective intelligence, we often think about it like a refinery where raw materials get transformed into valuable products like knowledge and solutions. But what if we think about it like mass apprenticeship that fosters people's talents? What if citizen science projects didn't just generate new knowledge, but also new PhDs who could go off and conduct their own independent research? Or what if open source software projects routinely trained novices to become senior developers? Wouldn't that be a deeper kind of collective intelligence where the intelligence is distributed throughout society, not just aggregated to the top? Wouldn't it make society more resilient to problems like coronavirus or climate change or poverty, where we need huge amounts of decentralized innovation and local adaptation? In this talk, I'm going to argue that we can use collective intelligence to teach innovation skills that will make society more people-powered and more resilient. I'm Spencer Carlson, and I'm a fourth year PhD student in the Learning Sciences department at Northwestern. So one of the challenges in collective innovation is you can get a lot of ideas that are low quality or unoriginal or impractical because a lot of the people are novices. So we've developed a few different ways of dealing with novices in collective intelligence. So sometimes we just avoid novices altogether and we target experts for contributions. And then other times we let the novices in, but we ignore the bad ideas because we're just using filtering and aggregating to pull out the best ones. And this works really well when there's some key authority who's receptive, who's ready to implement the best ideas. But think about problems like coronavirus or climate change. The authority to implement solutions is highly decentralized. It's spread across all kinds of governments, businesses, nonprofits, and individuals all around the world. So even if we could aggregate the best ideas into a centralized repository, this wouldn't be enough. We need to foster intelligence more deeply throughout society, and that includes the novices. Okay, so sometimes what we also do is we can carefully control novices by giving them tightly scoped tasks and detailed step-by-step instructions, like often this is what we do in citizen science. And this works really well when the task demands are predictable and similar for really large numbers of novices, because then what you can do is you can have a few core experts who are managing large numbers of novices by blasting out instructions that they can follow. But again, thinking about problems like climate change, people are coming up against local complexity and variation, and so they need to be able to adapt their plans. It's not really possible for a few experts to just blast out instructions for everyone else to follow. So we need to teach novices to plan and adapt for themselves in these problems. Then I'm just going to talk about one last approach. It's common in peer production. It's where we give experts special privileges, and then they can clean up after novices when necessary. And this works really well if you have an online platform with version control, because the platform designer can give expert users absolute power over the versions. But we can't version control the real world, right? So nobody has the power to undo carbon emissions that result if you have a novice innovation team that develops an ineffective solution for climate change. So to solve systemic problems where the authority to implement solutions is decentralized, where people need to adapt to local complexity, and where there's no fail-safe for reverting mistakes, we need a deeper form of collective intelligence that doesn't just ignore or overwrite low-quality contributions, but actually makes them less common by building innovative capacity throughout society. And we can do that by understanding learning and by thinking about collective intelligence as an educational process. So in this study, we looked at how collective intelligence systems could help us teach innovation. And specifically, we looked at how to teach a core skill in innovation, more effective iteration. Iteration is the core process that helps innovators manage the inevitable uncertainty in innovation work. And it has 3 steps. So first, innovators reflect on their current understanding of the problem and their solution. And then they identify risks, which are specific uncertainties that could lead their solution to fail. And then based on that, they choose strategies to reduce the uncertainty, like doing a stakeholder interview or building and testing a prototype. And so from here, you can see to iterate effectively, innovators need to know a lot about the different risks in their domain. So for example, expert policy innovators, they might know that there's a risk of designing a climate policy that's politically toxic, right? Nobody's going to vote for it. So if that's a risk in their project, then they might seek information about different politicians' views as a strategy to reduce their uncertainty about what kind of policy they might be able to pass. But novice innovators have a hard time planning effective iterations like that because they don't have this expertise yet about risks. So that's where some learning could be really beneficial to increase collective intelligence. So the good news is we found that novices can iterate more effectively when we give them checklists of risks to look for. So we could use this approach in collective intelligence systems. But there's a challenge because different innovation projects have different risks. So in policy innovation, right, you have that risk of designing a politically toxic climate policy. But that's not really relevant if you're designing a social support system for healthcare workers fighting the coronavirus. So if we want to have collective intelligence systems that help novice innovators learn effective iteration, we need a systematic way of surfacing the specific risks that are relevant in different projects so that the novices in those projects could iterate intelligently. So to understand how systems can help teach effective iteration, what we did is we prototyped this process for surfacing risks, and there's more details about this in the paper. But the result was a checklist of 49 criteria for identifying risks. And for the sake of time, I'm just going to highlight a few examples. So for example, an innovation team, if they don't have access to users, right, the people who are going to use their innovation, then this creates a risk that they won't understand what the users want, and they're going to create an undesirable innovation that's not going to be used. Or if the team can't articulate an argument for why their innovation is better than existing solutions, then there's some risk that their innovation is not going to have a comparative advantage, and so people won't adopt it. And likewise, if the team doesn't have an implementation strategy for how they'll build and diffuse their innovation, then there's a risk that it will never be implemented at all. So we can get novices to behave more like experts if they run through this checklist while they're planning their iterations. So what are the implications for this intervention for how we think about collective intelligence? Well, first, we're highlighting a different way of working with novices in collective intelligence systems. So sometimes we can use those first four approaches, but sometimes we want to create a deeper kind of collective intelligence by helping novices to learn. And this is especially useful, right, when we need a lot of intelligent contributors because solutions have to be implemented and adapted locally. So we can't just come up with a single great idea or a repository, because what we really need is a lot of great people. So in this model of collective intelligence, we're really thinking about supporting the processes of learning and teaching instead of primarily using systems to coordinate collaboration on complex problem-solving tasks. And then second, even experts might benefit from using a checklist of risks like this to plan their iterations. So we know from medical researcher Atul Gawande, checklists can radically reduce the rate of infection and deaths, even for really simple medical procedures that the doctor should know how to do without a checklist. And so maybe a checklist would also help expert innovators remember to do things like comparing their innovation with existing solutions sooner to make sure there's going to be a comparative advantage, or thinking through implementation sooner to make sure that it's feasible. And maybe this would help to reduce the time that experts waste on ineffective or impractical innovations. So again, this model of collective intelligence is thinking a lot more about how do we diffuse and develop people's expertise as a key outcome, and not just treating expertise as an input in a problem-solving task. So what's next? Well, based on these initial findings, we're starting to develop and test software to help people surface risks. And we also want to understand how this might work when you have a geographically distributed network of innovators where many of these interactions are happening entirely online. And of course, this is just one of the skills novices need to learn in innovation. It's the core skill, which is why we chose it first, but there are others we could teach as well. And I think, like, stepping back, what's exciting about this is the more that we understand how collective intelligence systems can help novices to learn innovation, then we'll be able to design technology that supports worldwide networks where novice innovators can learn to make local impact on global problems. And if we can do this, we're going to have a society that's more people-powered, more resilient, and more innovative. So thank you so much for watching my talk. To start our discussion, I'm going to ask you, how might you use learning to achieve deeper collective intelligence in the context that you've been studying in your work?